Hello, everybody. Welcome to my webinar. We are here today to speak about lifecycle design in architecture and in construction industry. And my name is Maryia Perthen. I'm Business Development Manager of the company eTool, and I'm going to give you 30 minutes webinar today. First of all, I'd like to ask you a question. Why you're here and why we are doing what we do. And I guess the answer is very simple. It's because we all care. We care for our environment, we care for our planet, and we would like the future generations and our children to grow up in as nice environment as we can enjoy it now. And we try to do our best to enable them this opportunity. So in the beginning, I'd like to speak briefly about lifecycle assessment and introduce to you eTool and provide a quick demonstration of the software for those who haven't heard about us, and then speak about carbon and zero carbon design and how you can use a software like ours for collaboration. So eTool is an Australian company, and they're based in Perth. I'm based in Melbourne, and eTool developed software that is called eToolLCD. There's a reason why it's called LCD. It's because we believe in lifecycle design, and we try to encourage everyone using it as a design tool rather than an assessment tool. And with this, you can measure environmental and financial performance of whole of buildings or whole of construction projects. It would be a building or a bridge or a road and so on. So eTool can act as a consultant, so we can also provide modeling and help to provide a life cycle report for a building. But we also provide our software for other companies, so everyone can subscribe and simply use it in-house to check their designs and make assessments. What is building life cycle? We like to think about a building as a living form that has a certain life, and it starts with birth, basically, where the materials this building consists of come from, and how these materials were produced, what's the extraction process, and this means that these emissions that are already in the materials will also flow into the building and will be considered. Building life cycle also includes the transport or transport-related emissions. So these materials coming from local suppliers, or are they coming from overseas? So this will be also considered, as well as the construction process, machinery, equipment that are used during the construction process, and finally the use phase, and that's where we speak about long-term operational phase of a building, and ideally it's 100 years. Green Star recommends 60 years. Unfortunately, the bitter reality is that nowadays buildings are built just for 15 or 20 years, and then it really depends on the redevelopment plans. But we should really try to reduce this future waste as much as possible, and try to design for longevity, and try to design buildings that would last for many, many years and can be used by our future generations too. So during this use phase, we would also assess maintenance, replacements of those materials that were initially locked into the building, as well as operational energy and operational water, and that's where we speak about operational carbon. And finally, end-of-life impacts, and what happens with those materials after the building will be demolished. Do they land into landfill, or can they be recycled and reused, and so on. So all this basically will be assessed. our software is compliant to different rating schemes, like LEED, BREEAM, Living Building Challenge, or basically all that assessment is part of the rating to assess materiality. And in Australia, the most important rating schemes are Green Star for buildings and E-Star for the infrastructure. You can also follow the link here and read more about these rating schemes. The features of our software are basically there are four main features, and the most important for you to know is that it's really a lifecycle design tool rather than assessment. It should be it would help you to guide your decisions, to help you to improve the design, to have a full transparency of impacts, and with this tool you can test different scenarios and create recommendations to your clients. Finally, you can also use it as a collaboration tool, and I spoke about it before. In a couple of weeks ago, we had here events in Melbourne organized by Movements Architects Declare and Engineers Declare, and they were speaking about a missing gap between architects and engineers in the design process, where the decisions that will be locked in at the architectural concept then later are defined through engineers in their design process, and that's where the software can connect this dot and basically serve as a communication platform between architects and engineers and further to construction company and your clients or authorities. We've also implemented a lifecycle cost feature, which means you can measure financial performance of the building or CapEx and OpEx. And this is really important because, as you know, sustainability comes to a cost, and it's a luxury good we are worrying about. Meaning that also any decision that you propose to your client can also be validated in terms of cost and should remain in realistic frames. Probably the most important and interesting feature for architects could be a Revit plugin, and also upload of CSV files. Basically, how to model building quickly and efficiently and not losing too much time in details. So if you have a BIM specialist in your organization, please reach out to me, and I'm happy to provide a separate session to talk about Revit plugin and to demonstrate how it works. Basically, it will mean that the software will translate a Revit model into the available templates and calculate the whole lifecycle assessment out of it. And there is a guessing mechanism trying to help the software to recognize all these templates correctly. And once this is done, the matching is complete. Then the next time you changed the Revit model and uploaded it back into the software will recognize all these changes and do the matching faster. As you can also see here some links, and if you want to learn more about these topics, you can simply click the link after I distributed this presentation and learn a bit more. So now let's talk about environmental impacts. As you know, we can measure environmental emissions through different impacts like global warming potential. Basically, this is all these global warming gases that are emitted into the atmosphere and that contribute to global warming. And there are different gases, and they're measured with GVP or CO2 equivalent measured in kilograms of CO2 equivalent. It's probably the most important one that everyone focuses on, but also there are others that should be considered in our opinion, like particulate matter that you can see. It raised significantly during bushfires in Australia, and basically measures the quality of air that we breathe in. Another thing to consider is what is carbon neutrality, and so how do we actually measure carbon of a building? And you probably heard about terms embodied and operational carbon. So what does it really mean? As I indicated before, operational carbon is it's all about our appliances and HVAC systems that use electricity, power, heat, and water in the house. And they contribute to emissions in the operational phase of the building. Whereas embodied carbon is locked into the materials that this building consists of, and they are kind of produced upfront and need to be considered as well. Currently, the proportion between embodied and operational carbon is about 30 to 70. So it depends really on the type of building, where is it in. Some projects, for example, in commercial space, they might even have 80% of operational carbon in there. However, the forecast produced by UN Environmental Global Status Reports and also by the architects says that this proportion is going to be almost equal by 2050, and I'm going to show you through the software also that it's pretty accurate forecast. As to measuring carbon neutrality, so in Australia there are different organizations that can help you to achieve this certification. One is the NCOS, or National Carbon Offset Standard Compliance Pathways. You've got Green Star Performance on Neighbours, but also EPD Australasia, so you can produce like a building EPD or a whole life cycle assessment of a building to calculate total embodied and operational carbon, and to show how much you would basically need to offset to become carbon neutral. And finally, Green Star also announced a new credit that will be published this year, and this will mandate that all buildings starting from 4 stars will have to look at their upfront carbon or their embodied emissions and reduce them by at least 10%. You can also see some webinars that we already provided, and they're recorded, and you can also learn a bit more about it there. So how do we actually measure operational and embodied carbon? And there is a very nice and holistic way to measure it, provided by an international standard, EN 15978. So this is basically our Bible, and this is a calculation method that helps you to calculate the whole emissions of a building. And I'm just going to jump into the software to show you how it looks. So our software is cloud-based, but it's also quite down to earth. And if you have a good internet connection, it's all there. You'll get a sample project, an example project, which is basically a one family house, one single residential house. And if you are a homeowner, you can even have a test and try to measure your own environmental impacts of the house using this sample project. All you need to do is to change the entities, units, quantities in these templates. And templates are bigger components the building consists of, so are basically our walls, floors, windows, doors, and also, of course, HVAC systems and appliances. So you see the total number, 750,000 kilograms of CO2 equivalent, and on the right you also can see the manual bar where you can select impact that you want to assess. So we chose here carbon equivalent, and And you can also select other impact categories or cost, which will make this model to a life cycle cost model. And this will help you to measure CapEx and OpEx over the lifetime of the building. Could be also an interesting exercise. But just wanted to have a look at the menu and see that you can already get a feeling of hot areas of this building where emissions occur, or what are basically our biggest contributors to CO2. And certainly this is going to be the biggest part will be energy related systems and appliances. And as a summary, you can see that this building has about 490,000 kilograms of CO2 equivalent over its lifetime, coming from the operational energy, which is about 2/3 of the total. You can also see that here are some products, or basically our upfront carbon that we lock into the building, but also some recurring impacts. And recurring means that we will have to buy some products again and reinstall them, or repair them, replace them, because some materials, like for example windows, will have a shorter life than the building's life, and that's why you will have to replace them maybe 2 or 3 times over the 60 years. So there will be some significant recurring impacts, which also means that the more durable and more long-lasting materials you're using, the better the performance will be of your model. Now I wanted to show basically all this operational and embodied impacts, how to calculate them. So on the project level, you can then switch on and off the modules that you don't need. And please don't get scared by these modules, but basically this is international standard I was speaking about before, and it describes where emissions come from. And just in short, modules A are the origin of materials. So this is upfront carbon. Modules 4 and 5 are construction process. Finally, the use phase, all the replacements, refurbishments, maintenance, and operational energy and water. End of life phase, deconstruction, and finally some benefits that you can generate through your design, like using some recycled materials, or open loop, or direct reuse, and maybe a PV system that not only satisfies your building needs, but also can fit into the grid, and this way give you some credits and reduce the total carbon. So to calculate operational carbon, you just focus on the operational impacts. You can just switch off those modules that you don't need. And vice versa, if you need to calculate embodied carbon, you simply switch off operational impacts, and then press save, and then calculate your embodied carbon. Another thing I wanted to show you that is really important to know is that the location of your building will really define these proportions between operational and embodied carbon. And for example, this building that currently has 2/3 in energy is located in Victoria, as you can see. However, if we would change this building and build it in Tasmania, for example, where grid is already quite green, then I want you just to remember this proportion was 2/3. Then the proportion will become completely different. As you can see, it became 1/3, or even less than 1/3. And materials and products recurring impacts will become more significant and will need to be considered. So be careful with percentages and numbers. It's really better to concentrate on total numbers, not to miss out anything. And that's why knowing that our grid will be decarbonizing so quickly, you also have an option to simply use a focused grid that will be decarbonizing faster due to a scientific paper that we were using here for this assumption, and as well decrease the energy proportion even further, so that, oh, excuse me, it somehow jumped back. So that yeah, the materiality and recurring impacts end of life will need to be considered. And this is not the future. This is not really like for the future. This is very, very near, and we all know that decarbonization will be happening faster than we think. Some other things I would like to show you are basically the templates that we've got. So we've got a big library of templates with all these windows, doors, and different materials that are there. So you can put your building together, just dragging templates out of the library. But we also have whole of building templates that can help you to simply use it one-to-one. For example, here's residential building, full story, NCC compliant. So it already has some minimum requirements in place, and it's a whole building. So all you need to do is simply to adjust areas and maybe replace one material through another in templates if this is not what you were planning to have in your concept. But this is really easy and fast way to run some strategies. And another thing is that we have, so after you've done the model, you can then start running different recommendations to your clients and check different scenarios. For example, you don't know how much carbon saving it will generate if you would replace concrete through timber or carpets through tiles, or use a PV system, or use a heat pump, or use some fancy lights and so on. So you can calculate these percentages of savings here and come to a certain number to show you the total carbon savings that this building helps to generate. And this helps you to really see all this very transparently, both operational and embodied carbon related emissions. So far so good. I explained a little bit about this standard that helps us to calculate carbon and to know how much you would need to offset. For example, if this project already uses green power, then we simply need to calculate embodied carbon to offset basically the rest. So you would need to deduct operational carbon from total and multiply it by the cost of offset. Current cost is between $5 to $100 per ton, and this specific building would, for example, need to purchase about $30,000 of offsets to become carbon neutral. But what is really carbon neutral? As you could see, simply switching to green power is and then buying offsets to offset the remaining carbon is almost a bit too easy. I mean, it's definitely a very good step and big step forward, but it will not help you if the building is using a low efficient materials that would not last, buildings that are badly insulated and so on. So all these things should be considered earlier. And so there are 4 simple steps as a hierarchy of carbon reduction that you could follow and remember. The first one is simply to avoid carbon intense products and materials. Secondly is to reduce. So try to reduce areas that are not necessary in your building, that maybe are just nice to have, but because they will use an unnecessary material that would produce this carbon. Also try to build light, reduce the mass volume of materials. Of course, you can also substitute some material through another that are less carbon intense, and finally offset the rest. We've got some projects that we reference on our website that did achieve carbon neutrality, and if you go on our website, you will see it in the projects tab. For example, this is Cape Peterson project that we assessed, and as you can see, we also have like our own little rating. So you can get eTool Silver, Platinum, and Gold for each category, like embodied carbon, operational carbon, total carbon. So you can see that this project helped to reduce total carbon by 103%, which is a gold medal due to our internal rating. And then you can read here a little bit what they really did to achieve it. There is another project, for example, low carbon mud brick home back in 2014, or zero carbon challenge winner, again similar performance. And as you can see, the assessment was done back in 2012, and now we've got to 2020, and everyone suddenly speaks about carbon neutrality, although this has already been happening a long time ago, and there were innovators out there that chose this path, which finally now becomes a bit more of a mainstream. And finally, I want to speak about collaboration. So the value of doing lifecycle design is really the highest the earlier in design you are, because on the horizontal line you can see the life or the time of the design process. So you prepare the brief design concept, then you detail the design in the middle, and then building companies are involved in the end. And the value of changes may be the highest, for the performance. However, there's also cost associated with these changes, and so the further in design, the higher the cost will be to implement any change, because materials will be purchased, contracts will be locked, and it's going to be almost impossible to even suggest any changes later on. And that's the gap we're speaking about between architects and engineers. Most of the decisions are locked at a pre-concept phase or at a concept phase, and that's where it's really in your hands to try to provide better outcomes for the environment. And basically, it's very simple. You just need to focus on the functionality of the building and its design life. So simply designed for longevity, and focus on functionality of building so that it really lasts longer. And how about you speak to your clients and try to convince them, maybe look at carbon of their projects, regardless any rating scheme. Let's say, how about we try to reduce carbon by 50%? It doesn't need to be 100% always, but it's better than nothing, isn't it? And also you can consult them and give them a list of recommendations, how you're getting to this 50% and what it's going to cost, and see how they would reply. It's about transparency and early discussions. You can see also lots of clients that probably are your clients as well, because we not only work with some architectural companies, but also with some engineering companies like Wood & Grief, Candle, Jacobs, Arab, Northrop, and so on. We also work directly with construction companies and developers and some universities. So it's about collaboration, and there's a feature in software that enables you this collaboration. You can have multiple read-only users that can view your models to discuss next steps. So yeah, I think I ran out of time, and thank you so much for joining my webinar. If you have any questions, please send me an email, and if you would like to check the software, you feel free to subscribe and to try it yourself for your projects. And if you want to learn how to use it, there's also a support site with many recorded videos. So please feel free to reach out for any questions, and let's simply build better buildings.